So we're going to talk about regression lines or lines of best fit. Least squares regression line, LSLR, or lines of best fit. We're going to go ahead and put in all this information about the yards per game and the points per game for Big 12 schools. And then we are going to plot the scatter plot, and we are going to find correlation like we did before by going to stat, calc, and then lin reg. Okay, we know we can graph as long as we have stat plots on. We have L1 and L2, scatter plot, graph. If we don't see it, we zoom 9, which is zoom stat. We get that. And obviously, I made a mistake here. So let's go back, and it looks like my Y is wrong, which is correct. 46.3, this should be 44.6. All right, I get that. And then I can calculate my correlation by going to stat, calc, lin reg, which is 4. This is the linear regression. And we get R, but we get other stuff. Our calculator says the linear regression y equals ax plus b is a is 0.102406, b the last point was 26.9 for 329. Well, this is how we find the linear regression. Our calculator does the job of doing all of the math provided to take your residuals that Party Sabetti was talking about and shrinking them so that they're the least, and then all of a sudden we create this line of best fits using a calculator. We get A, 0.102. We get B, negative 12.75. We get R squared, which we'll talk about in a little bit, 0.8877. And we get R, which is 0.942. And up at the top, they say Y equals AX plus B. Question?
Mine is only showing the A and B.
If your calculator only shows the A and B and not R, you have to make sure you turn your diagnostic on. You go to second catalog, go to the D's, A, B, C, D. If you press that button, you'll go to the D's and go to diagnostic on. Once you have it on your calculator, it will stay on unless you reset your calculator. Stats calculates lin reg 4. Okay. Well, what we get is our line of best fit. The equation y equals 0.102, and I probably should use more decimals to make sure it's super accurate, x plus negative 12.75. Watch what I can do. Everybody, go into your y equals. As long as you have this graph. If you have this graph, you're good to go. Go on your y equals and graph this line. 0.102x minus 12.75 or plus negative 12.75. I got 0.102x either plus a negative or just minus 12.75. And if I press graph, we will have our scatter plot graph, and our calculator shows us the line of best fit, which is great. Okay. Now, what does this model do? What does this line of best fit do? This becomes our prediction model. Okay. This is what we call a prediction line. Yes, it's the least squared regression line. Yes, it's the line of best fits. But in most cases, what we're going to do is use this line to help predict certain values so long as our correlation is strong. Any questions on getting this line and graphing this line? You go to y equals, and then go 0.102x plus negative 12.75. Okay? So we can use this line to predict how many points we can expect to score given a certain amount of yards that are gained. Do you need more time to put in the info?
It didn't work. So when I graphed it, it only showed
one side.
Mm-hmm.
Did I type one in twice? 581, 621, 666, 549, 498, 417, 461, 360, 348. Okay, let's go. Stat plots on L1, L2, graph, zoom, 9. There it is.
Yeah, when I did it, it was just showing 1 point.
Make sure you always zoom 9. Could have been your values were off. And then we'll put that line in, which was 0.102x minus 12.75. Okay? All right, so this is our prediction line. We can use this so long as we know what x and y means. What is the x in this situation? And what is the y? It's a very important question. We have this line, but if we don't know what x and y mean in the line, Ms. Jameson, then we're not going to know what to do with this prediction line. So what is the x? What does it stand for? No, in this particular situation, with this scatter plot of these points, what is x? No, it is not that. It is the yards. You were right. I didn't know what you said. The y is the points. Yards, points. Okay. This is the model that we can use. So if we have certain questions, like the following. The Oklahoma coach, Bob Stoops, predicts that he will gain 400 yards this weekend against Baylor. How many points can we predict they'll score using this model of Big 12 teams, yards per game, and points? Go, figure it out. Confusing, right? What do you mean? Well, if the Oklahoma coach predicts he's going to gain 400 yards, and this is the model that we can use to predict points based off of yards or yards based off of points, we can use that model because that is going to fit. That line is fitting perfectly, or as perfect as we can, the points versus the yards versus the points of these Big 12 teams. What do we get? Yeah, 28.05. What we do is we say, oh, well, if we're going to score 400 yards, you plug in 400, type this into your calculator, you get 28.05. Well, if you're Bob Stoops, maybe you want to, change your prediction because probably 28 points is not going to beat Baylor this weekend. Okay? Well, Art Briles, the Baylor coach, Art Briles says, you know what? Baylor's going to score 50 points this Saturday. Well, we can use this prediction model to predict how many yards they're going to have to gain to score those 50 points. Let's see. Let me grab this model again. Make sure it's down there. Oops. There we go. In this situation, I was given the points that the Baylor coach thinks he's going to score. But using this prediction model, I can figure out how many yards we can expect Baylor to gain based off of those points. $50 equals 0.102x plus negative 12.75. Let's remember back to our algebra days, solving for our variable. Question, Mr. Riley, you got the answer? Good. Well, Mr. Riley, I taught you algebra, so you better tell us how to solve for x in this situation.
Take 50 divided by 0.102.
Not first. You get rid of the stuff being added first. Then we get rid of the 0.102. Always get rid of the stuff being added. Don't worry, it's been like 4 years, Mr. Riley. Who knows who taught you Algebra 2, right? It wasn't me. Okay? I always say, I don't teach algebra anymore, that these are like the knights and these are the foot soldiers, and you need to save the princess. You got to get rid of the foot soldiers first, then you get rid of the knights, and then you save the princess. I will teach my daughter that. And what do we get? 615 yards. Oh, who knows? All right, well, turns out if you want to score 50 points, you better gain 615 yards. That's a lot of yards. Okay, of course, like there's other situations where, you'll score more points and gain less yards, or you'll gain more yards but score less points, turnovers, whatever, okay? But this is the prediction model, okay? How do we get the prediction model? Well, we take some data. We understand that this data is a strong linear relationship. We then create a line of best fit. That line of best fit makes this prediction model. We'll use that prediction model to be able to, predict certain things in the future. Okay? Now, one quick question. If a team, horrible team, gains 0 yards, okay? So, they need the ball every time. How many points can we expect them to score? Let's see. Let's see. Well, I got my prediction model, right? Well, let me just use that. Let's see. If the team gains 0 yards, y equals 0.102 times 0 plus negative 12.75. How many points can we expect that team to score? Negative 12.75. Does that make sense? What did Party Sabetti tell us? I'm glad you paid attention, Mr. Englander. What did she tell us?
That it only works within the
Yeah, it only works within the range. This prediction model all of a sudden is way off If you score 0, if you gain 0 yards, how many points should you expect to score? 0, right? Not negative 12.75. So Party Sabetti said, well, if you have all this data up here and you get a line of best fit, don't go too crazy with this line of best fit and start extrapolating it all the way to the right or all the way to the left. Because just like the heights and the ages, we can't say that somebody who's 60 years old is super, super tall, because that's way outside of the range. And we can't say that you're going to score negative 12 points, because that's way, way outside of the range, okay? So this is why we're careful with our prediction models. However, this Y-intercept, this is what we consider the Y-intercept. It's the Y-intercept when X is 0. This is, what you could expect if your prediction model could be used, okay? All right, let's go to the notes. We'll try to get through them quickly because we pretty much did the lesson right there. That was the lesson. So we'll fill in all the notes. There's one extra thing that we need to talk, which is variation and the variance, okay? All right, 2 main reasons why you want to use a line to fit a set of data. To find a summary or model that describes the relationship between the 2 variables. Thanks. To use the line to predict the value of y if you know the value of x, or the other way around. Predict the value of x given the value of y. So this is predict. Predict the value of x, which is the explanatory. Given the value, given the value of the y, which is the response. Sorry, I'm all off. Sorry. Oh no, it really doesn't matter. Doesn't matter. Value of y, which is the response. Given the value of x, which is explanatory. And then you should write right next to it, or the other way around. So it wouldn't have mattered. Okay, how do they use the line? How do they create this line? How does your calculator do it? Well, they take the distance between all of these points and a line, and they try to minimize it. Okay, so the vertical distance from an actual point to the predicted point on the line is called a residual. Okay, it's the distance between an actual point and the line of best fit. In this situation, the actual is located at 70, whereas the predicted is like 67. The residual is equal to your actual minus your predicted. In this situation, your residual would be 70 minus 67, which is 3. Okay? And what they do is they take all of the residuals for all the points, and they take a line and they kind of work it around, and they figure out which line would make the residuals the least when you add them together. Okay? So making the sum of the squares of the vertical distance as small as possible. And when you make the sum of the squares of your vertical distance as small as possible, the mean or the sum of your residuals is approximately 0. The line will contain the point of the means, the averages. So x bar, which would be the average of the x's. Y bar is the average of the y's. Okay, turns out every single line of best fit will have that point, which is very interesting. Interpreting the Y-intercept when x equals 0, we will get this predicted value for y, which is b. Remember, for lines in general, and put this on top, we use the line y equals mx plus b. That's the equation of a line, right? In your calculator, they say it's y equals ax plus b. A and m are the same. Just in algebra, use m as the slope, right? Well, now a is just going to be the slope. We'll talk about how we can apply the slope. B is going to be the y-intercept for both cases. Interpreting slope. Remember, slope, m equals rise over run. For every increase in x, there is an approximate m increase in y. Usually we're talking about a one increase in x. We will talk about an m increase in y. I'll show you exactly what that means. Let's look at our previous example, actually. We had a slope here of 0.102. This is the slope. This is the y-intercept. We already talked about that y-intercept. But the slope, you can write that as 0.102 over 1, right? All of a sudden, this is a rise over a run. What you can do now is to interpret this slope, you would say, for every one increase in the x, so every 1x, we are going to, one increase in x, we are going to increase by 0.102 for my y. Okay, well that's just for a regular line. In this situation, x and y has a context. X is yards and y is points. So it turns out every increase by 1 yard, we are expected to score 0.102 more points. So every yard gained, you can think of as almost points earned. Of course, you got to get across that goal line to actually earn the points, but this is just a prediction model. You gain yards, you'll score points. Okay? So back to that. That's what that means. Rise over run, typically we'll have a number divided by 1. We'll say for every increase by 1 for our x will be an increase of the number for y. Okay, now let's talk about variance. We know about R. R is the correlation. It's the strength and the direction of a linear relationship. R squared is what we call variance. R squared is a percent. Okay? If we looked back on our previous situation, R squared, 0.8879, we would read that as 88.79%. And I'll show you exactly what we will do, what that percentage means in a second. R squared measures the fraction of variation, the values of y, in the values of y that is explained by the variation of x. Variation in the values of y that is explained by the variation of x. If r is 1, r squared is 1, sure. And 100% of the variation of y is explained in x. If r squared is less than 1, then there's some variation of y is explained by x, and some is explained by some other factors. Of course, there could be lots of other factors, even when r squared is 1. So, r squared is equal to some percent. Okay? We would say the percent of the variation in y, and typically what you'll say is y is going to be the context, is determined by the variation in x. And same thing, you're going to use the context for what x stands for. So back to here, 0.8879, 88.79%. And if you have your notes out, this is what you'd write. You would say 88.79% of the variation in y, but instead of y in this situation were points, is explained by the change in x, or by x, which is the yards. I guess we should say variation in Okay? That is variation. Moving to the next page. Here's an example. Data on the association between high school graduation rates. So high school graduation rate is X. That's our explanatory variable. And the percentage of families living in poverty. So percentage of poverty is Y. I reported R squared value of 0.78. That's what was reported. Find R and interpret both R and R squared. Well, if R squared equals 0.78, let's just write our variation statement. Okay, I would say 78% of the variation in Y, but instead of Y, I'm going to say the percent of poverty is explained by the variation in X, which is the high school graduation rates. Okay, good. Now, if I give you R squared, how can you find R? Yeah, take the square root of both sides. If you want to solve for R, square root both sides. Well, what's the square root of 0.78? 0.88. All of a sudden the number got bigger, right? Because it's a decimal. Well, 0.8 means the relationship is strong, and we think it's positive, but we should know that when we take the square root of something squared, we know that this could be plus or minus 0.88. Okay, so we think it's strong, we think it's positive, but it could be negative. All we know that it is a strong relationship. Strong, positive, or negative relationship. Now, you can probably guess what the relationship is. If you have lower high school graduation rates, would your percent of your families living in poverty be higher or lower? Less people graduating, more poverty, right? So one's going down, one's going up. Is that positive or negative? That's negative. So you would probably assume that this 0.88 would be negative, right? Through intuition. Okay, we talked about finding that line. Let's do one more example of finding a least squares regression line, or this prediction model, using this data. Go ahead and find your Y equals AX plus B prediction model, and make sure you denote what A stands for and what X, I'm sorry, not what A stands for, what Y stands for and what X stands for. That way, that'll help you with your predictions that we will be making in the future. We have household size and weight of discarded garbage in pounds, probably per week. Clear out your Big 12 data. Go ahead and graph the scatter plot. You know, it's good to always see it. Zoom 9. Then you see it's a strong positive relationship. As there's more members in a household, they're going to produce more garbage. Go ahead and find the exact prediction model, the least squares regression line, by going stat, calc, lin reg. You've done this to find R, but it gives you more information than just R. Turns out we get the equation Y equals, here's the A, 3.4744 times X plus the B is 15.853. And then go ahead and graph that in your calculator. Get rid of that other line that had to deal with yards and points for Big 12 teams. Let's go to this, which is members of the household and garbage. And you should see that line fitting nicely into your data. Okay? Now, what does Y stand for in this line? Garbage, right? These were our X's, these are our Y's. So this is our garbage in pounds, which is dependent on our independent variable, our household size. Very important to have this down because that will help you with the next questions once we get to the kind of end. All right, we kind of looked at the scatter plot. We drew a rough sketch. You don't have to draw a rough sketch because you did the graph. Now let's interpret the meaning of the slope. Okay, the slope, this M, which is A in this situation, is 3.4744. Now to turn it into a slope, I like to put it over 1. That way I have a rise over a run. This is my Y. This is my X. That's slope, right? Change in Y over change in X's. That means for every 1 increase in my X, I will increase by 3.4744 in my Y. Instead of using X's and Y's, you can change that into garbage and house size. So go ahead and write that statement down, not using X and Y, but using garbage and house size. For every 1 increase in this, there's an increase of 3.4744 in this. For every 1 increase in house size, garbage discarded will be increasing by 3.4744 pounds. Y over X, rise over run, slope, there's the slope. Okay? Y over X. X, in this case, is house size, Y's is garbage. Part C, interpret the meaning of the Y-intercept. Remember, the Y-intercept is the B. In this situation, this was M or A. This is B. Almost done. Means 0 people in the house gives you 15.853 pounds of garbage. Does that make sense? No, if you have 0 people in the house, you should be producing 0 things of garbage. This is why we don't like to go too far outside of our range. What was the value of R? What did we find the value of R was? 0.937. Strong, very strong, positive relationship. Linear relationship. Value of r squared was 0.878. We would say that 87.8% of the variation in y, which is the garbage, is determined by x, which is the house size. Finally, we can use our regression to predict the weight of the discarded garbage for a family of 5. I would say y equals 3.4744 times 5 plus 15.853. I get my value. What do I get? 33.22. I could also be asking you a question for how many people will be in a family that produces 50 pounds of garbage. You'd go 50 equals 3.4744, solve for x. And finally, we can find the residual for this certain situation because we have an actual data point at 5. Remember the residual, which we don't use often, but just for an example, the residual is your actual minus your predicted. Your actual in this case was 34.79. The predicted that we got was 33.225, which is a residual of 1.565, which just tells you that it's good. You know, the residual is small. It means our model is pretty good at predicting for around this range. Okay, thank you very much. Start working on your homework, unless you're portaled. Okay, go ahead.